Berlin, 1940, the year of triumph. France had collapsed in 6 weeks. A nation that had fought Germany to a stalemate in the previous war crushed beneath German military might. The Wehrmacht had proven unstoppable. German engineering, German discipline, and German tactical innovation had revolutionized warfare. In this moment of absolute certainty, with the entire continent bowing before Nazi power, Adolf Hitler made a decision that would determine the fate of the war just as decisively as any battlefield victory or defeat. The decision was to stop believing in radar. Not completely, not immediately. But fundamentally and fatally, Hitler chose to reject the very technology that German scientists had pioneered before Britain and America had truly begun to take radar seriously. In late 1940, with German forces victorious across Europe and the German leadership convinced that the war would be won within months, Hitler issued a general order. No scientific research was to be undertaken unless conclusive results could be guaranteed within 1 year. Germany would not spend resources on long-term research projects that might take years to bear fruit. Victory was coming. The war would be over before those projects matured. Why invest in technologies that would arrive too late? This decision was born of confidence, but it was a confidence rooted in catastrophic misunderstanding of what American industrial and scientific capacity truly represented. Hermann Göring, commander of the Luftwaffe, endorsed this view completely. When warned about the potential of radar development, Göring dismissed such concerns with contempt. Radar was a secondary technology, he believed. Britain could use it if they wished. German pilots had courage, skill, and superior aircraft. Technology was less important than the will of the warrior. This fundamental miscalculation would haunt Germany for the remainder of the war. What Hitler and Göring did not understand in 1940 was that they were not choosing merely to pause radar research. They were choosing to allow their enemies to pull ahead in a technological race that would determine the outcome of battles, campaigns, and ultimately the entire war itself. Britain and America, lacking Germany's early technological lead, but understanding the strategic importance of radar, accelerated their research even as Germany slowed. The gap that opened in 1940 would grow wider with each passing month and year. By 1942, German military commanders began receiving reports that disturbed even officers trained to trust in German superiority. Allied bombers were finding targets with uncanny accuracy. Aircraft seemed to locate German ships and submarines with impossible precision. Fighter interception seemed less a matter of skilled piloting than of being guided to the enemy by some invisible force. German intelligence officers and commanders proposed theories to explain these phenomena. American pilots must be exceptional, some suggested. The Americans must have some technological advantage that German spies had somehow failed to uncover. But what it could be remained a mystery wrapped in frustration and concern. Then, in February 1943, a captured aircraft provided the answer, and it was far worse than German military leaders had feared. A British Sterling bomber, shot down on the night of February 2, 1943, near Rotterdam, carried aboard a piece of equipment that would shatter German confidence in their technological superiority forever. The aircraft crashed before its crew could activate the self-destruct explosives designed to obliterate the radar equipment. The device fell into German hands largely intact. It was transported to Telefunken's laboratories in Berlin, where Germany's top microwave specialists gathered to examine what would become known as the Rotterdam device. Professor Leo Brandt received the recovered components on February 5, 1943. The magnetron itself was small, barely 10 centimeters across, machined from a single piece of copper with 8 cylindrical cavities arranged symmetrically around a central cathode. The engineering was elegant, compact, and unlike anything German radar specialists had attempted to build, Brandt's initial examination revealed something that would send shockwaves through the German scientific and military establishment. The British had achieved what German theoretical physicists had concluded was physically impossible. The cavity magnetron generated microwave frequencies at wavelengths of approximately 10 centimeters, corresponding to frequencies around 3 gigahertz. German radar experts, including some of the Reich's most distinguished physicists, had studied the theoretical possibility of such microwave radar and rejected it as impractical. Their calculations had suggested that at these frequencies, insufficient energy would be reflected back from distant aircraft to be useful for detection. The antenna arrays would have to be impossibly small to focus such short wavelengths properly. The engineering challenges seemed insurmountable. So German research had proceeded along different lines, using longer wavelengths that required massive antenna arrays but that German scientists believed were more practical. The British apparently had solved the problem that German theory said was unsolvable. A working group was assembled at Telefunken, immediately designated the Arbeitsgemeinschaft Rotterdam, or Rotterdam Working Group. The task was clear: determine exactly what the British had achieved, how they had done it, and what implications this discovery held for German radar development. The first meeting occurred on February 22nd or 23rd, 1943. Over the following weeks, German scientists methodically reverse-engineered the complete H-2S radar system using wreckage recovered from the crash site and components from the magnetron itself. What they discovered horrified them. The magnetron's design revealed that the British had not simply made an incremental improvement to existing radar technology. They had created an entirely new category of radar. Using shorter wavelengths allowed much smaller antenna arrays, which meant radar could be mounted in aircraft with relative ease. The rotating antenna scanned a 360-degree arc beneath the aircraft, with returns appearing on a plan position indicator display that created a map-like image showing coastlines, rivers, cities, and terrain features with remarkable clarity. The implications were devastating. An aircraft equipped with such a radar could locate targets on the ground even in darkness, even through clouds and fog, with an accuracy that German defenses had no means to counter. The H-2S system could be used for blind bombing with precision that transformed air warfare. Pathfinder aircraft equipped with H-2S could mark objectives for other bombers following behind, enabling night bombing raids of unprecedented accuracy. German defenses, which had been optimized to counter radar operating at longer wavelengths, were rendered obsolete by this new technology. But the devastation went deeper than mere tactical problems. The Rotterdam device revealed that Germany was not merely behind in radar development. Germany was a full decade behind in fundamental understanding of microwave physics. German scientists had theoretical knowledge of magnetron principles. British physicists had published papers in scientific journals during the 1930s, and even Russian physicists had written about magnetron theory in 1936. German theorists had read these papers, but German scientists had concluded that the theoretical principles could not be translated into practical engineering at power levels useful for radar. They were wrong. Professor Otto Hachenberg, assigned to write the technical analysis of the captured device, understood the implications immediately. His report, written in May 1943, contained conclusions that would echo through German scientific and military circles for the remainder of the war. The British magnetron represented not an incremental improvement to radar technology, but a fundamental breakthrough in microwave engineering. The Germans did not lack theoretical knowledge. They lacked the practical engineering expertise to translate theory into functioning equipment. More fundamentally, they had dismissed the possibility of success before attempting it seriously. The psychological impact on German scientific leadership was devastating. Hans Hollmann, a German physicist who had patented magnetron designs in 1935, was forced to confront the reality that his theoretical understanding had been correct, but his engineering assumptions had been fatally wrong. German scientists had believed that generating useful power at microwave frequencies was fundamentally limited by the laws of physics as they understood them. The British had proven this belief incorrect. Now, in February 1943, Germany was facing the need to develop its own centimetric radar technology, and it was years behind. The Arbeitsgemeinschaft Rotterdam attempted to copy the British design. The task proved extraordinarily difficult. The magnetron required precision machining of extraordinary quality. German factories, already under strain from the demands of conventional weapons production and increasingly disrupted by Allied bombing, could not produce the necessary components. Cobalt shortages made it impossible to produce the permanent magnets required for some designs. Copper was scarce. Precision manufacturing equipment was fully committed to other production. By May 1943, German efforts to produce copies of the captured magnetron had yielded only 4 working devices. The British, meanwhile, were mass-producing magnetrons at the rate of thousands monthly. American factories, equipped with the technology through the teasered mission of 1940, were producing magnetrons at even greater scale. Germany faced a technological gap that was not merely temporary, but fundamentally structural. It reflected not merely a delay in development, but a difference in industrial capability, manufacturing precision, and the ability to sustain high-volume production of complex equipment. What made the situation catastrophically worse was the timing of the discovery. Had German scientists captured the magnetron in 1941, Germany might have dedicated resources to developing centimetric radar, despite Hitler's decree limiting research to one-year projects. The pressure of American entry into the war in December 1941 might have shifted priorities toward long-term technological development. But the capture came in February 1943, after 2 years of German complacency had allowed the technological gap to widen to an unbridgeable distance. The first German centimetric radar system, the Fuji-40 Berlin, was not introduced until April 1945, just weeks before Germany's surrender. Only about 25 units saw service before the war ended. By that time, Allied radar had advanced beyond the capabilities of the early centimetric systems Germany had finally managed to produce. The delay had cost Germany years of technological development that might have enabled the creation of effective countermeasures or defensive systems capable of dealing with Allied radar-guided weapons. The consequences manifested across multiple theaters of war simultaneously. In the Atlantic, German U-boats that had once dominated merchant shipping lanes found themselves hunted by radar-equipped aircraft that could locate them at night on the surface where they had once been safest. The centimetric radar installed on Allied patrol aircraft rendered the German METOX receiver, which had provided warning of Allied radar, useless because it was calibrated to detect longer wavelength radars. Suddenly, German submarines died in darkness without warning, without comprehending what was killing them. U-boat commander Heinz Schaefer later testified that Allied radar had shattered the power of the U-boat overnight. The Battle of the Atlantic, which had seemed destined to strangle Britain's ability to receive supplies and continue the war, turned decisively in Allied favor once centimetric radar became widespread. This single technological advantage may have been more important to Allied victory than the material resources supplied through Lend-Lease. The ability to detect German submarines made Lend-Lease possible by allowing convoys to reach Britain safely. Over Europe, the consequences were equally devastating. The American SCR-584 radar system, which operated at microwave frequencies and provided automatic tracking of aircraft with unprecedented accuracy, revolutionized anti-aircraft defense. German pilots diving on anti-aircraft positions found shells exploding in their future flight path, calculated by machines faster than human reaction time. Individual courage and piloting skill became irrelevant when facing an automated system that calculated intercept points with mathematical precision. German pilots, trained to believe that superior skill and individual heroism could overcome technological disadvantages, confronted a reality that shattered their confidence and their morale. Adolf Galland, the German fighter ace commanding fighter defense, sent urgent reports to Göring describing systematic destruction of Luftwaffe aircraft by what seemed to be impossibly accurate anti-aircraft fire. Johannes Steinhoff, with 176 confirmed victories, confronted Göring directly in January 1945. "We are not fighting enemy pilots anymore," Steinhoff said. "We are fighting mathematics. Individual skill has become irrelevant." Göring's response was to relieve Galland of command and threaten courts-martial. The leadership could not accept that technological superiority had made traditional military virtue obsolete. But the evidence was overwhelming. German fighters were being destroyed at rates that no amount of courage or skill could compensate for. Radar-guided anti-aircraft systems were calculating firing solutions faster than human pilots could react. The radar specialists in Germany understood the full scope of the disaster. Dr. Wilhelm Rune, who had worked on German radar development, admitted after the war that German leadership had refused to acknowledge American technological capabilities, even as the evidence mounted throughout 1944 and 1945. "We created elaborate theories to explain impossible anti-aircraft accuracy, rather than accept the simple truth." They had better technology, Rune recalled. "We dismissed every report that contradicted our assumptions about American capabilities." This cognitive blindness, the refusal to accept that Americans could innovate and achieve technological breakthroughs that German scientists had deemed impossible, reflected deeper cultural assumptions within the German military and scientific establishment. The Wehrmacht had pioneered military innovation in the 1930s. German engineering was renowned worldwide. German scientists occupied leading positions in theoretical physics and mathematics. To admit that American engineers had surpassed German science in a crucial field was psychologically impossible for many German leaders. But the refusal to accept reality did not change reality. The gap revealed by the Rotterdam device in February 1943 was not a temporary disadvantage that could be overcome through heroic effort or clever tactics. It was a fundamental structural advantage rooted in American industrial capability, American theoretical understanding of microwave physics, and American ability to mass-produce complex equipment at scales Germany could never match. Hitler's 1940 decree limiting radar research to one-year projects had reflected his confidence that the war would be over within months. That confidence was not unreasonable at the time. France had fallen in 6 weeks. The Luftwaffe appeared to have superiority over the Royal Air Force. Invasion of Britain seemed possible, but France was not America. The Battle of Britain revealed that confidence in rapid victory was misplaced. Germany would be fighting a long war against enemies with access to vast industrial resources and scientific talent. In such a war, long-term technological development was not a luxury. It was survival. The irony was profound. Germany had possessed early leadership in radar technology. German scientists had pioneered electronic detection of aircraft. The Seetakt radar installed on German ships in the late 1930s was arguably more advanced than British radar of that era. If Germany had chosen to accelerate radar development rather than pause it in 1940, if Göring had not dismissed radar's importance, if Hitler had not limited research to one-year projects, the history of the war might have been different. Instead, Germany allowed that early advantage to slip away. Britain and America, taking radar seriously as a strategic technology, accelerated their development programs even as Germany stagnated. By the time German leadership recognized what had happened, the gap was too large to close. The resources required to catch up were unavailable. The factories were being bombed. The materials were scarce. The time had run out. When German scientists examined the captured magnetron in February 1943, they were not merely examining a new radar component. They were witnessing the moment when Germany's fate had been sealed. The technological superiority that America had achieved in radar was not an isolated advantage. It reflected American ability to invest in long-term research, to mass-produce complex equipment, to sustain innovation across multiple fronts simultaneously. The same advantages that had created the cavity magnetron and the H-2S radar were creating the SCR-584 anti-aircraft system and dozens of other technological innovations. Germany could not match this. Hitler's 1940 decree had made clear that Germany did not believe it, needed to. Germany was supposed to win quickly, decisively, and completely. Radar research that would bear fruit only after years of development was incompatible with that strategy. But the strategy itself was fatally flawed. The war did not end in 1941 or 1942. Germany found itself fighting a prolonged conflict against enemies with greater industrial resources and, increasingly, greater technological superiority. The Rotterdam device represented the moment when German scientists confronted the full scope of this miscalculation. The cavity magnetron was not the only American or British technological breakthrough that Germany faced. But it was perhaps the most significant, because it revealed how far behind Germany had fallen in a field where German scientists had believed themselves superior. The psychological impact was shattering. Confidence in German technological superiority, already shaken by defeats in Russia and North Africa, collapsed completely when confronted with evidence that Germans had deemed physically impossible. In his final analysis of the Rotterdam device, Professor Heichenberg wrote that Germany had not failed because it lacked scientific knowledge. Germany had failed because it lacked the organizational structure, the industrial capacity, and the political will to translate knowledge into practice. Hitler's decree limiting research to one-year projects reflected a military strategy based on quick victory. That strategy had failed. But by the time German leadership recognized the failure, the opportunity to develop alternative approaches had passed. The cavity magnetron story reveals a fundamental truth about modern warfare. Technology is not decided on battlefields. It is decided in laboratories and factories, in the decisions of leaders about what research to support and what industries to expand. Hitler's dismissal of radar in 1940 proved more consequential than any tactical decision made by any general in any battle. The decision to pause long-term research made when victory seemed certain ensured that Germany would face enemies whose technology had matured while German development stagnated. When German scientists finally produced their first centimetric radar units in April 1945, they were producing 1942-era technology while their enemies were years ahead. The symbolic significance was undeniable. The nation that had pioneered radar development faced defeat not primarily through loss in battle, but through technological obsolescence. Hitler's refusal to believe that American radar capabilities could exceed German understanding had proven catastrophically wrong. German scientists had proven it to themselves when they examined that small copper magnetron in February 1943 and recognized in that elegant, compact device the shape of Germany's defeat.